Hi guys, in this video we're going to talk about Pythagorean theorem and its converse. Your objective is to use the Pythagorean theorem and its converse. These notes are available in Canvas for you, so you can download them if you haven't already, and I recommend that you do that so you can follow along. Right. The theorem 8.1 says if a triangle is a right triangle, then the sum of the squares of the legs, or the lengths of the legs, is equal to the length of the square of the hypotenuse. I think that's missing a word there. That should say, hold on. That should say right there, it's equal to the square of. All right. You guys know that as a squared plus b squared equals c squared. Okay. Remember the legs are the pieces that make the 90-degree angle. So this is a leg and this is a leg. So A and B are legs. Okay. The hypotenuse is always the longest side. It's always across from the 90-degree angle. So that's the hypotenuse. Okay. And so you guys were taught that as a squared plus b squared equals c squared. Okay. So a Pythagorean triple is a set of numbers that satisfy a squared plus b squared equals c squared. So 3, 4, 5 is a very common one. 5, 12, 13 is another one that shows up quite a bit. 8, 5, 17, 7, 24, and 25. So they work because 3 squared plus 4 squared equals 5 squared. Right? 5 squared plus 12 squared equals 13 squared. And you can check those on a calculator if you want to. Okay, so that's why those are Pythagorean triples. So if I square the two smaller sides, add them together, that should be equal to the square of the longest side. Okay, it turns out that if the side lengths satisfy the Pythagorean theorem, then it's a right triangle. Okay. So if we look at this problem, it says a triangle has side lengths of 85, 84, and 13. Is this a right triangle? Explain. Okay, so you want to identify your pieces. So which one is the longest? Which are the other two sides? So C is the longest. Okay, and so that's going to be out of 85, 84, and 13, that's going to be 85. Okay. And then the other two are A and B. It doesn't matter which order you put them in. So I'll just call that one A and that one B. Okay, so we're going to say A is 84, B is 13, and C is 85. Okay, and so then I'm going to check if I square 84 and 13 and add them together, does that equal 85 squared? Give me just a second to pull the calculator. Typing does most into my calculator, so bear with me just a second because I forgot to bring my calculator in here. So 84 squared plus 13 squared is equal to 7,225. So 7,225, and I just did that on the calculator. 85 squared is also 7,225, so they are equal. So the answer is the triangle is a right triangle. Okay, and that's because a squared plus b squared is indeed equal to c squared. Okay, and so that's how you test. If it were not equal, then it would not be a right triangle. Okay. All right. All right. So we use Pythagorean theorem to solve problems. And so one of the ways that we do that is by solving for missing lengths. And so we can identify A, B, and C and use Pythagorean theorem. So I'll just label my sides here so that I can use Pythagorean theorem. A squared plus B squared equals C squared. And I'm going to plug them into the appropriate place. So 12 squared plus 35 squared equals x squared. So using my calculator, I'm going to type in 12 squared plus 35 squared. And that gives me 1369. And that's equal to x squared. And then remember that when you are solving and you have a square to undo squaring, we do the square root. So I'm going to take the square root of that. Of 1369, and that equals 37. Okay. So x equals 37. Okay. And you can solve the next problem the exact same way. Go ahead and pause the video and just give it a try. Okay. Hopefully you've paused the video and you've gotten 7 squared plus 9 squared equals x squared. 7 squared plus 9 squared is 130. And when you square root that, you get a decimal. Okay, and so it said to do this in simplest radical form. And so that involves simplifying the square root. So I'm going to kind of talk you through that process so that you've seen it and you can kind of come back to this. So square roots, when I did the square root on number 1, 1369, the square root of that is 37 because 1369 equals 37 squared, right? And so when I take the square root, I end up with just 37. All right, so we're going to take 130 and we're going to break it up into things that we know are squares. So let's see, it's divisible by 5. So 5 and 26. Well, 26 is 2 and 13. And so I've prime factored this, and there are no doubles. So that's going to be my answer. Okay. I will make and post a separate video on simplifying square roots so that you guys can have that as a reference. And so I will upload that later. Okay. I want to add a problem on here that's not listed because both of these solve for the hypotenuse, and I want to talk about solving for the leg. All right. So let's say the hypotenuse is 12 and the leg is, one of the legs is, let's say 4. We want to solve for the other one. Okay, so what we're going to do is we're going to set it up 4 squared plus x squared equals 12 squared. Okay, I'm going to go ahead and there are multiple ways to do this. I'm going to go ahead and calculate these squares. So I know 4 squared is 16 and 12 squared is 144. Okay, so now this is just solving an equation, right? So subtract 16 from both sides. Right, and I get x squared equals 144 minus 16 is 128. And so if I take the square root of that, I'm going to get the square root of 128, which I could possibly simplify, but I'm not going to right now. And so we're just going to leave it as the square root of 128. Okay. And so I will post that video later about simplifying radicals. Okay. So just, I'll let you guys know through school status and in Canvas announcements when I have posted that. Okay. The other thing that I'm going to ask you to do with Pythagorean Theorem, and you're going to have a couple of days to kind of work on this, because I'm going to give you some IXL things to do, is the triangle inequalities. And so let me pull it up. So with Pythagorean Theorem, we're doing a squared plus b squared and equals c squared. Well, if that is true, I know that that's a right triangle, right? That's the whole premise behind the Pythagorean Theorem, and it's converse. And so it turns out that you can also use that to classify these triangles as acute or obtuse by using the same premise. So I can look at a squared plus b squared, and if it is greater than c squared, then I have an acute triangle. Okay, and that would look like this, right? And so you can see if this is A and that's B and that's C, where they are, how C would be shorter, right? And so then if A squared plus B squared is less than C squared, then I have an obtuse triangle. Okay, and that could look something like this. Okay, so that's A, that's B, that's C. All right.